And now the ACK from the first ACK actually is good because now we don't care about the outer fragment because it wouldn't have sent an ACK if it had an out of order fragment that hadn't been received. But also to close down the connection completely, we need the ACK coming back from the far side. So what I wanted to make sure is the model that you have is already covering this case and is not going to, one, if we force this out of order fragment that comes in later, that it doesn't get dropped, and two, that it will receive both ACKs, otherwise we won't close connections properly. So I guess that's a question that we wanted to put out there because VFP does it quite differently. They just see the fin and then they set a timer and then they wait that specific period of time, which is quite long, by the way, and then they take down the connection. I don't want to do that. It's very wasteful.
So can I comment on this, Gerald?
Mm-hmm.
This is John. I think like if you really want to like remove the connection sort of as aggressively as possible, but allow those ACKs to go through, then like the proper way to do that would be that the fin itself has a sequence number. And then the subsequent ACK would have to be the ACK for the sequence number that covers the fin. So like there's significant logic to be able to like track the sequence number and the acknowledgement on that fin, associated with that fin packet. But if you do that, then like when you get that final ACK, you know that it's the final ACK and you could immediately remove the flow.
Right.
Rather than waiting 5 seconds or longer.
Right.
So
and that's what we want to do because remember in VFP they're doing like 20,000 connections per second. They're not as worried about us who are talking about like millions of connections per second.
But we do need a timeout, right?
A timeout is just a regular ager. Like you already have that.
Okay.
So I think what John was saying is you could just actually look for the sequence number of the ACK to make sure it matches, and if it does, there's an ACK. As long as it does match, then we're clear to shut that down. And I think that's the fastest way to get it shut down, and that's what we want. We don't want setting. First of all, timers are really expensive,
yes.
And so it'd be far better to do it this way. But we were looking to see if Marion's model is even covering this. I'm sorry, Marion, I didn't read the P4.
Not yet. Not yet. However, when working on the proposal for SCI APIs, we actually, in the example, we covered fin, FinACK, and ACK. I will also incorporate that into the model.
Okay.
And I will need to take another look into how out of order packets will be handled in that case.
I think you don't have to worry about the out of order. Because once if you do what John was saying, just say this ACK must match the sequence number of the fin, then don't worry about the out of order packet. It means that if the ACK comes back, it means that the TCP has received all the packets.
Right.
Yeah, so we weren't really looking at the sequence number. We were just looking at the flags. Like first, you need to you are in the state of waiting for fin. Then you move to the state of waiting for FinACK. Then you wait for ACK. After that, you
but there may be
I understand that, but that doesn't solve the problem.
There may be many ACKs because like you could send a fin when there's like lots of outstanding ACKs. And like many ACKs could come after the fin, but like only one ACK will come that like covers the sequence number of the fin, and that's the final ACK.
Right. So what I'm saying is probably I will need to improve not only to look at the sequence of the flags, but also at the sequence number of those packets that I expect to get. I agree with you.
Right.
So that's and so this is solving two problems. One, we just wanted to know if that was covered properly, but two, you don't have to worry about the out of order fragment. Just forget about it now, because this covers that scenario. And that's
This
the one that
covers-
we
Yeah,
have
yeah.
to really,
This covers Andy's scenario then, the non-first fragments? This covers
you got-
Andy's non-first fragment scenario in the chat window?
oh, I don't have the chat window. If Andy's, he can ask the question himself. I don't know.
Oh,
Oh,
non-first IP fragments have no L4 ports in them. How do you want to classify them? Do you want to classify them in the context of the first fragment being combined with it somehow and then make the classification? Or do you want to write your policy rules so they explicitly say what should happen to non-first fragments regardless, without having to know what their L4 ports are?
So it doesn't cover it, okay.
I don't know. It has nothing to do with timing unless you want to combine all the IP fragments together so you know what their L4 ports are before classifying them.
Okay.
Yeah, and there's a flow cache issue because of that reason as well. If you, try to do this connection tracking for defragment and for non-fragmented packets. So maybe,
I'm not sure I understand this. The first fragment should have everything we need.
Right,
Why-
but
why-
fragments have
have
nothing.
L4, does not have L4.
Pardon? Other fragments we don't care about. We only care about the first fragment.
L4.
You don't want to drop non-first fragments? They won't get through. Nothing will get through.
What do you mean drop non-fragments?
Oh, so you don't. What do you want to happen to them? How do you want them to be classified according to the policy?
Anjali was explaining this. in-
Assembly, right?
Yeah, I mean, so Gerald, maybe like if you remember.
Explain to Andy like what you're supposed to do there.
I think Andy knows.
So the intention is we're never reassembling anything. We're just a go-between, right? We're just a switch essentially to everything. So that's, we're not going to reassemble anything. So,
Anjali, please go ahead.
Yeah, so the question I think Andy is asking, and I have the same one, is the first packet, because it does not have L4 header, how do you, what tuple do you use for classification? Because that would mean only the L3 parts, and that would classify differently than your rest of your packets. So.
well, I think that first fragment has the L4 header.
Sorry,
It's
yeah,
the other ones you're talking about.
sorry, okay. Yeah, the first fragment has the L4, the other don't. Sorry, I mixed my words. Yeah.
Yeah, the first one needs to have, right? Because otherwise there will be no way for us to know what we will be matching this against.
Right. But
Right.
but what they're asking, Michael, is like, I'm not even sure this is true, that the rest of the fragments have no L4.
That is true.
Yeah.
So how do you do classification on something that has no L4, Michael?
Yeah. So what has happened, Gerald, in the past is like if you look at RSS and stuff, you have the input set that is used for fragmented stuff is just based on L3. It's never L3 plus L4. So that, like if you're classifying to a single queue, right? Or whatever. Otherwise, you end up with the first packet going in one queue and the rest of the packet going to other queues. So, I mean, I'm just giving you RSS as an example, right? But
Yeah,
similar
we
stuff.
we can't be classifying a layer 3 though. So actually, Michael, it's a good point. Do we even support fragment? Like this kind of tells me that I'm getting mixed messages here. How could we support fragmented messages if there's no layer 4 in it?
Yeah, so we have a thread with VFP team, right? And I will just exactly read what they mentioned, but I'm not an expert of how exactly they are handling this, right? They mentioned that NI site, like we use both IPs and the IP IDs to group all the fragments of a single packet together, and they also use number of NCAPs of the fragment. And they are saying that on inbound they expect each fragments to have the necessary NCAPs. But I understand that this doesn't answer fully the question with regards to lack of L4s. So the VFP didn't answer this fully in the email that we asked them to do this, right? I think they pointed only to some like external documentation saying that the customer can send jumbo packets if they want, and they will be fragmented in the VNet, and there is some link, let me just paste this link, but I don't believe this link covers this. So I don't think this we have this question fully answered yet, how exactly they are handling this.
Okay, so when you're gonna need to understand that, otherwise the behavior model is not
Yes.
complete.
Yeah,
While
I
you
agree.
were gone though, Michael, one thing we did agree upon is forget this fragmentation stuff for a second, just how to finish the connection. That you will finish the connection by looking at the fin, looking at the sequence number of the fin, and making sure that the acts match
It's
that.
the last one. Yeah.
Yeah, it's
Yeah.
the last one. So the sequence number has to be the same, and that way, when we get the second act in, we can close down the connection safely, and that all packets have already been sent by that time because we would get the acts otherwise. So we've kind of solved that problem, and then I think Marian has said that he will update the behavioral model to do that, and now we kind of moved on to how we ever got to that conversation, which is this fragmentation.
Fragmentation, yeah.
But it turns out that there are two different problems. One is how do you safely shut down a connection? And the second one is how do you deal with fragmentations?
We're trying to recall here like something that we saw that talked about like virtual reassembly and like a fragment cache and like it seems like maybe like dealing with fragments is like a stateful thing, but maybe you don't have to buffer all the packets. But I'm just like talking off the top of my head. I don't have like a full recollection of this.
I can
Either do I
think
it's
I can add the
gonna
top
need more.
three approaches I know of for handling this in the public GitHub issue that Microsoft folks can read and consider. But I'm not trying to drive it. I'm just trying to get to the requirements they want.
Yeah, Gerald, Christina, I think for the fragment stuff and like actual packet handling, right? We should involve someone from the VFP team, right? Because neither of us right now on this stuff. Maybe Gohan, because like you have some experience with the switches, right? Maybe you have some details or prints, but I know that I don't have exactly information how the VFP handles the fragments and how they are matching this, and they will know. So we need this team to also join us potentially in some discussion, which are on those kind of specific topics.
Maybe I can just make one small comment. When I talked to the VFP team, Michael, this is super generic, but they did say the first fragment should contain all the headers needed.
Yeah.
We can send through to determine the action needed and apply to the rest of the traffic. Okay, how they do that, I don't know, but that's what they said.
Yeah, the first fragment, I know that definitely they are waiting for the first fragment, right? Because like otherwise they have no way to basically match the policy, right?
Yeah.
But the question is like how they later match the rest of the fragments.
Exactly.
Yeah.
They say they
If they
do
don't
it,
have
but
L4?
they didn't say how they did it. Yeah.
Yeah.
And
I
apply
don't
to the
think we need
rest.
an answer today, but if you know who to follow up with, that'd be great.
Yeah.
Yeah,
How
we
about
have our
that?
team. We kind of started following up in the email, but the answer that they gave doesn't have yet the answer for exactly of the implementation, how they are doing this, right? It was too generic so far.
How about back to gap?
So I think, I mean, you use a fragment ID to match it, right? So what is the problem for that?
How some hardware fast paths can't do that, and some can.
Can do what?
Use the
Sorry, say that
fragment
again.
ID.
Buffering indefinitely and matching up fragments by ID and L3 source and dest IP. It's the buffering part.
Okay. We don't want to be doing reassembly.
Right, it's not reassembly. I think, again, I think like basically the fragments have like temporal locality, right? Like the fragments, all the fragments in like the full packet are going to be like pretty close together in time, right? So there's temporal locality. So like caching of like some kind of a fragment cache, like maybe works. Because like you're just trying to cover the time over which like those fragments from the given parent packet like exist. And so like I think the solution involved a fragment cache, but and not buffering the actual packets, but just maintaining like the flow information associated with that packet, like the 5 tuple.
And I wonder, can we maybe, I'm not quite sure if this is done right now in Harder, but what about the sequence number IDs to kind of do this together, like in a way, the range of the IDs, right? So whenever packet arrives, we can always, for example, store what was the sequence number ID of the packet. If this is the newest one, we will take it, right? And then we know that the retransmission of the sequence for the ACKs, right, will be for some like current sequence minus X, right? And we expect in this case to match the packets for the like 3-tuple, in this case, like a source IP, destination IP, and the protocol, plus the sequence number according to the range, right? I'm not quite sure how viable it is. I'm not so much familiar with full data path, but that's also potential approach that can potentially avoid caching.
So I feel like I don't know what's the problem, right? So is this on the receiver side assembly problem? How do we do the unfragmentation, assemble all those packets, and we don't have information for that, or we want?
No, there's no
We don't-
store
we
destination.
don't
It's more
wanna
like
do
forwarding
reassembly.
appliance, right?
Yeah,
So John,
we're
you were
switched.
saying something, I think, Gohan, and you were saying at the same time.
I was going to say it's like effectively like doing reassembly, but without buffering. It's just maintaining state, but not maintaining the actual packets and not actually doing the reassembly. And to have some cache of some number of those that you can have in flight. I think that that's the solution. I don't understand all of the logic of like implementing that, but I think that it's a stateful thing in order to deal with the non-first fragments.
Yeah, and I think that's true, John. You don't need to buffer packets as long as they come in order. If they come in out of order, then you would need to buffer.
Or drop them and let them be retransmitted, right? Yeah.
Why not just forward them?
You still need to
The
buffer
sequence
them,
number
right?
is close
So
to them.
I mean, I don't understand that, because the first packet arrives, you have to wait until the second packet, until the last packet all arrive, and you sample one packet and deliver, right? So.
No. The issue here is that you can't do the 5-tuple classification of the fragments if they're not the first fragment, right? So how do you apply the SDN policy? How do you do a flow lookup like on the non-first fragment? And you can do that if on the first fragment you maintain some kind of state and some kind of cache, so that when the following fragments come in, you've saved off like what the 5-tuple is or what the L4 information is for the subsequent fragments. And because, I mean, the fragments in theory should have temporal locality because
Yeah.
it's started as a big packet.
But are we saying like are we controlling both the sender side and the receiver side? Do we have the assumption?
No, but so I think this like one thing is like policy lookup, right? For this we need the first fragment which have everything, right? And I think the problems we are discussing is mostly the lookup for the.
No, not Michael. Sorry, Michael.
Why
No,
not?
I'm asking a question like, do we control both sides? The fragmentation and the defragmentation, both sides are we in our control or we are not?
We are not. So one side can be over the internet, right?
Of course, but we're doing encapsulation, right? So and doing decapsulation. On both sides, we are in control, right?
No, the user sends the fragmented packets and we encapsulate that. We can't change their payload.
No, user never send the fragment packet, right? So it's always wait to the fragment. The user
We
not
don't
send the
fragment. We don't.
No, we
fragment
do.
Packets.
No, we do.
Who
For you.
PHP can fragment the packets in case basically the customer sends the bigger one. Yeah, so the
For
clamp it,
UDP, we never do this for the TCP traffic, right? So we only do this for the UDP traffic. Because for the TCP, I think we should have in the spec, but I don't know if we have that. But there's a MSS clapping technique that we use so that whatever the customer negotiated MTO will be clapped by the by this SDN appliance layer, right?
So Gohan, if you are saying that we control fragmentation, what is your idea that what we could potentially do in this case if we control both the servers and destination?
Oh, it's just that we do not, they want to flow ID, something kind of to do the classification to a particular flow, right? So I think at the sender side, you can inject some information in the encapsulation layer, and then at the receiver side, you can extract that flow ID and then map to the flow, right? So because you add when you do the fragment, right? So it's you do the fragment, not the customer doing the fragment. Therefore, you can inject all those metadata information in your encapsulation layer, and those metadata will be consistent and transferred to the receiver side, and receiver side can use that metadata to extract the flow ID and get the things, right? So.
Yeah, but remember, these things are landing on existing VMs. So one VM, which is attached to an appliance, has nothing to do with the far side VM, which is not attached to the appliance, really. It's just a.
So that's what I'm saying. Do we have control on both sides, right? So I think
I would say we should assume we don't, because we are also, for example, sending some packets to, let's say, on-prem, right, with different devices and this kind of stuff. Like, so I think it would be nice, but I think it's a very strong assumption that we control both sides.
But if we don't have control, right? So if we don't have control, I think one side must be the VIP, right? So because of the existing deployment, then I think we just need to ask the VIP to give us what exactly algorithm, the secret sauce they have.
Yeah.
On the other side, and then we do it on our side, right? So I think they're talking about the encapsulation layer. I think they may have something there. Then we just need to figure out what it is.
I know that VFP, because there was some company that was asking us to correctly handle fragments and this kind of stuff for the UDP, and I know that VFP introduced some caching. So to this kind of stuff. So I'm not like, probably they have some, like, they definitely have some way of how they are handling this, right? It may be that they require caching, so some buffer and those kind of stuff, right? And the question is like, if not, then it's awesome. So you have different algorithm, right? If they require caching, then the question is like, how big caching can we do on the hardware, and can we avoid it, right? And the interesting observation that I want to mention here, that the connection establishment is not really a problem, because the first fragment will have the 5 tuple. So the main thing is really look up to match the existing flows, right? And I'm just wondering, and right now it's like brainstorming, right? Because all the fragments have a sequence number. And John, you mentioned that is this like time locality, right? That for example, the fragments will not arrive too late, not arrive too early, this kind of stuff, right? So I was wondering, like, if we do, but it's like example of the brainstorming algorithm, there can be also different approaches, right? If we do 3-tuple match, and if this 3-tuple match, after this 3-tuple match, we need to match the sequence number to be within the last sequence number that the packet saw plus minus X, right? And if it returns one single match in the flow table, then we know it's for sure for this. If it returns more than one single match, then we can always discard the packet and allows that basically them to actually retry till we get this. So this will be slightly slower. Potentially, this will solve it.
Yeah, I think that makes sense. I think that's how it would work. But I think the 3-tuple match would include the IP ID. Like, all fragments of the same packet have the same IP ID, and then like the sender that's doing the fragmentation like increments that IP ID for like the next packet that's being fragmented, the next packet that's being fragmented. So like the 3-tuple lookup makes sense. And then of course, like you can check like sequence numbers and make sure that the packets are like, the fragments are in sequence. Ultimately, you need a cache of those. You don't need to store the packets. You're not doing actual reassembly. You're just trying to like store the 5-tuple that's associated with that 3-tuple.
Yeah, but simply we always need to store the 5-tuple, because basically the flows needs to store it, right? Because like part of the flow creation, we need to keep it anyway.
You do, but you need to associate now like a 3-tuple with a 5-tuple in the case of like when you received like a first fragment. Because the first fragment has the 3-tuple and the 5-tuple, and then the following fragments just have the 3-tuple, right? So like you need to have some kind of a cache, just like you said, and like how big is it? What's like the logic for if you got fragments out of order, do you drop them? Like there's like a lot of like details around that fragment.
Yeah, I think we can understand, the algorithm can be designed, but what is the SL for UDP packets? Do we really have to do them in the hardware? I mean, why can't we say, this fragmented UDP packet, go to the CPU and let the CPU to do the defragment? Why do we have to do the fragmentation in the hardware? It's UDP, right?
Yeah, the CPS, like number of packets per second processing as well. Not so much CPS, the connection per second, but PPS, right?
Yeah, we're not sending any. We don't send any data path to the ARM cores. Gone. We do millions of connections per second. You send
yeah, but that's
anything
for
to
the
ARM
TCP,
cores.
right? So what's our SL?
So wait, but for the UDP, it's so from our point of view, the CPS. So let to clarify the idea, right? So the idea that why the CPS is slow, because basically just the rule processing is slow, right? Because we don't have a fast engine to process the rules, right? But the rules are being hit by both TCP and UDP packets, right? So we want to basically optimize the rule processing engine, so we can handle basically this kind of like new packets that we haven't seen of the existing flow evaluation fast, right? And the interesting stuff, this is maybe also the question for the FPGA team, because they offloaded, because like all the flows that gets created by the VFP, they always get uploaded to hardware right now. So we have it right now, right? So right now, every single flow that is created, we already offload to hardware. So the solution of matching the packet to existing flow on hardware level is already solved on FPGA, right? So we can potentially ask FPGA to tell us how exactly they solve this kind of stuff. So I don't believe the matching of the existing flows is the stuff that we need to rediscover. I think this is already there in hardware, right? And we just need to potentially use it, right? At the same point, I'm not quite sure if FPGA handles fragmentation. That's an open question. Maybe they don't, and maybe they just basically ask the customer to retransmit to get this in order. That's an open question.
But I think for this meeting, there might be other priority topics that we could find out the answer later after you guys do your homework.
Yeah, we'll have to do some more work on that one.
So back to the behavioral model then, or is it closed out? Okay. So we have more gaps we're looking at in the behavioral model that you guys have seen, as you've been looking through it, or?
I mean, I have like a small list here, but there's probably a bigger list if I iterate.
We can start with we'll start with the smaller list, sure.
So I didn't see anything in the behavioral model that kind of separates out sort of fast path and slow path. The documentation talks about the slow path as, the ACL, the route lookup, insertion into the flow table. And the documentation sort of shows the fast path as you hit in the flow table and you just apply the transforms. And so, like, is the representation of slow path and fast path logic supposed to be in that behavioral model? Or is it such that you can just do slow path on every packet from a behavioral model perspective, and we're okay with that?
We are okay with it. So basically, like, if this doesn't impact the PPS, right, for the already established connections, right, we can do the slow path for the existing ones, right? Because the fast path, like hitting first the already established transposition, right, the flow, right, it's mostly important from 2 points of views, right? One point of view, which is basically we don't need to do entire rule processing, which may have lots of prefixes, right? It is much faster, so the PPS is much faster, right? And the second thing, the HA scenario, because in case we have two cards which are talking to each other or two switches which are talking to each other, they need to exchange the state, right? And the idea is that the goal state, so the rules that we are plumbing, is eventually consistent, which means that because those are in the two physically different locations, right? There will be no way that we will guarantee that they will get applied at exactly the same milliseconds and this kind of stuff, right? Which means that once the customer establishes the flow needs to work in a specific way that it was established, otherwise customer connection will break, right? So that's why part of the HA is like once one device creates the flow and sets up the specific transposition based on that current rule, that time, this flow basically needs to be kind of transformed to the backup appliance in order, because like because the main thing about the HA, right, is one device dies, we can lose packets, but we cannot drop established connections. That's the main goal.
So like HA is like a whole big topic, right?
Yeah, that's a
this was like a much smaller point, just that the specification like describes slow path and fast path. In one case, the slow path does like the full ACL, the route lookup, all that, inserts the flow. The fast path does just the transformations. And I wasn't sure whether the behavioral model should represent fast path and slow path, or whether like from a behavioral perspective, there's no difference from saying like every packet just goes through the slow path.
I don't think anybody will implement it that way. I've heard that, but that's you'll never get the CPS out of it. But it's still one piece of code. It's like you always do the flow lookup. If you don't get a hit, you do the rest of it. So it's only one behavior, really. It's just how far do you go? Do you end at the flow lookup, or do you end? You do the flow look, and then you have to follow it up with the full slow path.
Right, I get it. I mean, the fast path is like a shortcut, you know, that you can take after the flow is established. I agree with you. Probably everybody will implement some kind of optimization to do fast path. The specification kind of specifies it that way, but the behavioral model doesn't implement it that way. And are we okay with that? And like, I was trying to get at this like maybe a week ago when I was asking Michael about like updates to the configuration, because like in my mind, if the behavior you want is like you're going through the slow path on every single packet, then an update to the configuration would be like immediate. But I think the answer we got a week or two ago was that no, like updates to the configuration don't have to be immediate. And like even for existing flows that are already established, like that updates to the configuration would have to be applied to those existing flows. But
not immediate, exactly, yeah.
But they can be applied like a little bit more lazily. They don't have to be applied immediately. So like I understand all of that, and I think I understand what we need to do to implement a data plane. But when I look at the behavioral model, it's just implementing the slow path. And
okay.
I think the main thing why maybe there is no part of this like fast path behavioral model, because at least this was my kind of assumption that the fast path is just the lookup in the flow table, and kind of like every single vendor for sure has already some flow tables functionality and is doing the lookup for those kind of stuff, right? So that's why it is kind of like documenting what is already established way of looking up packets in the flow table to kind of match it. Because the main thing that differs here, because like at the end, after the transposition, basically this goes uploaded to the flow table, right? With all the potential metadata to kind of do the transformation, right? So that the entry in the flow table will have just always, for example, the source kind of packet metadata, which is like a 5 tuple, which was originally there, right? And whatever other fields are required to match, right? And then the information about what's the final transposition to, for example, at 1 encap, at 2 encaps, and this should be the outer header, this kind of stuff, right? And then, look up in the table. Yeah, I think it's potentially beneficial to also document exactly how to do the lookup there, especially from the fragmentation also perspective. So we can also potentially spend some time to document the fast path as well, and do behavioral model for the fast path.
I think so, because we're going to find all kinds of exceptions to when we do HA and other things, that if we don't try to keep this model close enough to how people are going to implement, it's really not going to cover down the road as things get more complex, all the cases. And I don't know why it wouldn't have a fast path in the behavioral model. It's going to come up later somehow. Even when you do memory sizing, you always include the flow table. Why? Because it's the biggest table of all, right? And that doesn't even consider that there's even such a thing. So It wouldn't take anything for them to implement the fast path as part of the behavioral model. Why wouldn't, the question I would say is why not? Why not implement it?
Maybe
You can always,
and is that a difficult thing to do, Marian?
I'm trying to understand why the difference between slow path and fast path should be reflected in the behavioral model, since different, even within our company, different generations of the hardware will have differences between what goes into the slow path, what goes into the fast path. I don't know how we can generalize it with the behavioral model. Like, what if in 2 years we can do learning in hardware? So now we need another behavioral model for that?
what do you mean learning? We're already doing learning. We're doing the slow path is the learning part of it. What do you mean?
I mean, today the exception.
Fast path just means you've already done all the processing. So you don't need to do it on every single frame henceforth. Why would you?
Okay. So sorry, my definition is different. My understanding of fast path is different. Okay, this is reflected in the behavioral model. Like, if it's not the first packet of the connection, we already know about this flow. We are not doing the processing of the ACLs and other stages for every consecutive packet of the flow. It is already there.
Okay, so that matches the documentation. So why, John, do we think that it's not there?
I mean, maybe I'm not understanding the P4 code. I'm not a P4 expert. Maybe I'm not understanding the P4 code, but like, I didn't see the flow table. Like, the only flow table I saw in there was the connection table, which just basically only like had the state of whether like it was established or not. I didn't see like transforms or anything like in a flow table.
So there is, I can actually send you a link to exact place in the code, but there is an explicit verification. If the connection is established, then we do not do ACL lookups.
Okay. What about the route lookup?
Route lookup, in the behavioral model, route lookup happens every time.
Okay, so you don't have like a flow table with like the route, the transform that came from the original lookup when you ran the slow path. I mean, maybe that's what, I mean, from a behavioral perspective, that may be fine. But it's like, doesn't match like the spec is trying to like provide guidance on like what you should do in a slow path and what you should do in a fast path. And like, like you're saying like, okay, like we'll skip the ACL, but we'll still do the route lookup. Now, maybe that's how your implementation will work. Maybe a different implementation might store the route entry itself in the connection table.
And you have every right to do so. It doesn't change the behavior.
Right. It's just what it's just that it's like when you read the spec and you look at the behavioral model, it's not like obvious to me, and it's fine. I mean, I'm okay with it. Like if the behavioral model says it's going to do the route lookup on every single packet, as long as what Michael said before, that like updates to the route table don't have to be reflected immediately in the data plane. Which, you know, because like, for example, let's say you stored the transform in the connection table. Well, like it may not be that easy to take a route update and now propagate it to every flow in the flow table. So that's going to take time, and that can be done lazily, like we understand, but it's like the behavioral model doesn't, to me, the behavioral model sort of says, oh, the route configuration would just be like immediate because every packet is doing the route lookup. It's not being cached in the flow table.
And also, FYI, if you guys need some information how we are doing this in VFP, in case basically there is a config change, they usually increase something which they call like epoch number of the, but not for the card, but the ENI, right? And each kind of like flow that was offloaded has this number. So whenever packet comes, then they basically notice that that doesn't match, and then they invalidate it and redo entire kind of like slow path again.
Right. Reevaluate, like reevaluate the route lookup and the ACL maybe, right? Like reevaluate those because there's been a config change.
Yeah.
Right.
But it happens in this case on the config change, right? And not for every single packet, right? So
yeah, I get it. Like on the config change, you update like the epoch for the ENI, and then every flow entry has the epoch for which it was valid at that time. And when there's a mismatch, you know that the configuration's changed for that flow, or like on the and then you can reevaluate that flow and update its epoch. Right. So
with this epoch update, also interesting stuff that came up as we were doing also work on some different stuff on our side, right? Is that we notice some differences between hardware versus software, right? And the idea is, for example, in a software we model things per ENI, which means that even if, for example, let's say 2 ENIs may belong to the same customer VNet, let's say, right? The same customer virtual network, the same VPC, right? So the VPC shares mappings, right? So all the mappings between kind of addresses that are used for transposition are common for the VPC, right? And 2 ENIs may be belonging to the same VPC and may accidentally land on the same card, right? So in VFP, all the state is actually copied per ENI. So in this case, the VPC, even though it's potentially global object, right? It is not handled as a global object. It is basically copied per ENI, which is not very efficient, this kind of stuff, right? But at the same point, all the updates are kind of like updates the epoch always separate you on both times, right? And here, one thing that I want to make sure that in this case, for example, let's say the mappings change on the VPC, right? Then there is also a need to know which ENIs potentially, or which flows belonging to which ENIs needs to be handled. And I know that there was some approach that a team tried to, in this case, okay, if potentially multiple ENIs could be impacted, then let's not use ENI-based epoch, but let's use card-based epoch, right? So every time when anything changes in the configuration of the card, in the respective of the ENI, they change the epoch on the card. But this goes different behavior that, like, if one customer is churning the configuration, is impacting the performance of the other customer is on the card if the epoch is global. So that's why epoch cannot be global, right? At the same point, we would prefer the epoch to be, for example, per ENI. At the same point, understand that there is a complexity because the best efficient way to handle the objects like VPC is to have them kind of global and potentially referenced, because this is like one set of mappings. It will be more efficient to store them, especially if you want to keep basically 1 million mappings per VPC, right? But this requires some ability to track that if there is an update to the VPC, potentially those other ENIs, epochs needs to be incremented. So just FYI that we run into this before, that because some objects potentially can be shared by different ENIs, we can definitely implement them as a copy, right? But at the same point, it uses lots of memory. So those object VPC should be most likely global. At the same point, the incrementing epoch on the global card level causes this problem that one customer can affect the other customers if they were constantly reprogramming this, and we also don't want this to happen.
Right. I thought the mappings were like scoped to the ENI. You're saying like that's like too local of scoping, that like multiple ENIs might want to share mappings, but like that wasn't clear to me. I mean, I think like we were assuming that that mappings were like scoped to the.
I can tell you that the mappings are per VPC, right? So mappings are inside the VPC, and the ENI will be kind of like peering with one VPC, which is on VPC, or potentially some other VPCs, right? And it really depends, like how many, for example, customer will deploy VMs and this kind of stuff, right? Because they may deploy, for example, only one single VM, each customer, this kind of stuff, right? In this case, even though there will be like, let's say 10 ENIs on the card, right? Each of them will belong to completely different VPCs, right? but there is some potential optimization that we can use from the hardware implementation of the placement stuff, right? In case, for example, two ENIs are referring to the same VPC, to have this VPC not be copied because VPC can have up to 1 million mappings, right? So in this case, but this will be the same, right? From our control plane, we are okay to, for example, if the mapping for one VPC changes, to update always VPC1 and VPC2, because the ENI will refer to VPC1, the ENI VPC2, even though underneath is the same VPC. So it makes sense to consider this a hardware, and most likely the mappings will be in the hardware in the memory to kind of, and there are a significant number of them, right? 1 million, right? So it makes sense to make them potentially as a top level object, not per ENI object, and having ENI be able to refer to this top level object.
Yeah, it's like an indirection, right? It's
Yeah.
like there's an indirection you need from ENI to mapping table to mapping, right? Okay, I mean, that's fine. I have one other thing with the behavioral model was like I didn't know whether UDP was implemented in the behavioral model. Like it
No.
looked like it was just TCP.
Yeah, right now it's just TCP.
Okay.
Well, it definitely needs to include UDP. And it needs to have IPv4 and IPv6.
Right.
In addition.
And then I had one question that I posted today. It has to do with like enforcement of connection per second and enforcement of flow table limits, connection per second limits and flow table limits. Like where are those limits enforced? Like would they be enforced in the DPU? I know like the throughput is not enforced in the DPU.
That's right. That's right. They would be enforced in the DPU. So we can give you some examples there. Let's say I have multiple VMs going to the same DPU. We may oversubscribe, but we can't make it unlimited. So let's say a 2-core VM goes through this appliance. We actually need to limit that to some much lower number. So it's not going to be millions of connections per second. It might be like 50K connections per second for a 2-core. If we didn't put limits there, then the 2-core could essentially couldn't reach millions because it wouldn't have the bandwidth to do it, but it could certainly reach much higher. And so if we want to oversubscribe, we have to at least have some, we need to know by what, right? So if you make things unlimited, oversubscription just becomes a nightmare. Like it's just a total guess. But when we impose the CPS limit and the table size limit, we can slightly oversubscribe that, Nick, knowing that just through experience that nobody uses the maximums of everything at the same time. But if you don't do a max, then you're in nowhere land. You're just like you really can't do that calculation. It's one VM could literally, if it was big enough, dominate the entire NIC.
So what's the scope of those limits? Is it scope to the ENI? Is it
yes, to
scope?
ENI.
Okay.
ENI.
And like my understanding is that you're going to take like the flows from a single ENI and spread it over lots of DPUs, right? So
that's the bandwidth. Yeah,
that's for splitting the flow and also this kind of stuff. Yes, but in this case, we will
you'll divide
because because we'll divide this limit like to by this kind of stuff, because the flow splitting will also be like equal, like from the point of view like the standard distribution should be basically redirecting them equally with the hash function.
So like in Gerald's like example, 50K connection per second limit, if that gets spread across 10 DPUs, each one would be set at 5,000 connections per second.
Yeah, probably have a little bit of buffer, but because
we'll definitely have some buffer. Yeah,
perfect.
Right, and then
we'd give it a little.
The same with the flow table size limits per ENI, right?
Yeah.
And like, how accurate does that have to be? I mean, like, can there be a little bit of fuzz on that? Like,
it would be it would be fuzzy in that it would be a bit bigger. When you split it, you pretty much have to go a bit bigger because, you know, it's not perfect.
Right.
But customers don't care if they get a little bit more CPS or a little bit more table. What
Right.
they
I guess that's
do
what
care about is they don't get enough.
that's what I'm asking is like how much because also like in the implementation of this, like in the data plane, there might be a little bit of like tolerance that you need, like that, like it might not be possible to hit like an exact, but to have a little bit of tolerance in that number.
Yeah, it will be, but the tolerance will always be upwards, which is part of the oversubscription. Right?
Okay.
So do you guys want to turn this into an every 2-week subgroup, or do we just want to consider this a one-time meeting, or does anyone want to help with the behavioral model? We're almost at about a minute.
I think so. So next week is for the planning, right? So next week definitely will not have a meeting, right?
No.
And that's also we can have potentially like once we get maybe those added, like let's say UDP, those kind of stuff, right? And potentially the fast path, or maybe the fast path is already there, right? Into behavioral model. Maybe then on the email we can decide if you want to meet to additional like look into this or something like this, right? And this will be like 2 weeks from now, for example.
I think we need some kind of subgroup, to be honest, like just like Sonic has subgroups, because you can't have everybody in an audience who doesn't write data path, who really doesn't know the details of fragmentation or TCP or whatever. It's impossible to get the designs done with that many people. The subgroups are to bring more like-minded. So if you're like a data pathy type guy that's really into the details of how to do that, this is the right subgroup to be talking about those details, because look at all the things that got brought out today. Perfect. That's what you want.
Can we write a couple of to-dos here then to help out? We need UDP. Can you guys chime in and I can write a few things here? I think Marian said FastPath was already in there.
Fragmentation was the other thing that we need to look at.
Right,
in general.
And then the sequence number tracking for the fin, in final ACK.
Yeah, got to make sure that that model's updated.
Gerald, does the Dash document talk about the connection rate limits and stuff? Or enforcing it, between...
Enforcing limits, definitely. Even this subgroup eventually, not like right now, because we're trying to do some background work for you guys on like metering, telemetry, counters and stuff, but eventually that has to be talked about and put into the behavioral model.
Yep.
Marian,
but I think the people who want to attend this subgroup are the people who are like data path coders, like people who actually do that for a living.
Marian, can you think of anything else you need help with here?
No, but I was thinking that probably the sequence tracking and FinFinEck, this is something that I already had started working on, so I was
sure.
I probably wanted to add that.
Yeah.
In the nearest future.
We just want to make sure we share with the community what we're doing. That's all. So everybody has a common understanding and learns together. But yeah, agreed. You're going to have that soon, so that'll be a crossed off thing. Great.
Did anyone want to help with UDP or think about it?
We will definitely need the UDP. We cover UDP in our current designs, right? Like that's going into our network. We have to do that.
Okay, well, if anyone can, throw something into the GitHub and tag Marian, please. Okay. We're at 1 hour and 2 minutes. Anything else?
Yeah, good first start. Good meeting.
So yeah, Christina, sorry, my internet connection was very, very bad today. But definitely we can meet bi-weekly or tri-weekly as you prefer.
Okay, thanks.
I think bi-weekly at first, and then if there's less to do later. See, once
Sure.
my concern also is that, okay, we're all on VNet. Okay, great, but we have 7 service models. And at some point, if we can get the VNet done, then maybe we can start splitting up this work. I don't think it has to be done serially like it's being done today. But let's get through VNet first. And we can see how we could split up some of this work.
Okay. Thanks, everybody. And I think I mentioned to the larger group that we have Microsoft has, our org, not all of Microsoft, has a quiet week next week. So I sent the cancellation for the community meeting, and we have to focus on planning, and gives us time to think about different things. And so and I know, John, you're out the 23rd.
Right.
So, okay.
Right.
All right.
Yep.
Thanks, everybody. Appreciate your time.
Thank you.
Thank you, guys.
Thank you.
Yeah,
Yes, okay.
thank you very much, guys. Awesome.
Thanks, Gerald. Bye-bye. Thanks, Marian. Everyone.
Thanks, bye.
Bye.